In this presentation, we will go to discuss about the fuels and combustion process. That is quality of fuels and the combustion process in SI and CI engines. First, we will go to discuss about that in the comparison between the SI engine and CI engines. In petrol engine, during the suction stroke, air fuel mixture is drawn from the carburetor. But in CI engine, that is diesel engine, during the suction stroke, air is only drawn from the atmosphere. In petrol engine, carburetors use it to mix the air and fuel, that is for required proportions, that is homogeneous mixture. In CI engine, fuel injector is required to inject the fuel into the cylinder in atomized form, that is called here heterogeneous combustion takes place. In petrol engine, the spark plug is used to ignite the fuel air mixture. But in CI engine, fuel is ignited automatically by high pressure, high temperature air. The compression ratio varies from 6 to 10 in SI engines. At the same time, in CI engine, compression ratio varies from 12 to 23. Because of this, its weight also increased as compared to SI engines. It is operated on petrol auto cycles. The diesel engine operated for diesel cycle. The initial cost is very less for SI engines, but diesel engine initial cost is very high because of the engine design and construction is as compared to petrol engine. It is very complicated, and thermal efficiency is petrol engine is low, but CI engine is considerably high. Next, in the fuels for SI engines, the gasoline, it is the major product for the petroleum industry and forms most of the SI engines fuel. The mixture of various hydrocarbons such as parabens, olefins, naphthalenes and aromatics. These are, that is the requirements of the ideal gasoline. It is ready to mix with the air and afford uniform manifold distributions. It must be a knock resistance. It should not free ignite, easy to handle, it have a higher calorific value. It does not form gum and varnish formation. In the fuel is very clean, does not produce any corrosion. That means the corrosion on that engine parts. Okay, these are the requirement of the ideal gasoline. Next one, important qualities of the SI engine. First one, volatility. It is one of the main characteristics properties of the gasoline which determines its suitability for use of in SI engines. Since the gasoline is a mixture of different hydrocarbons and volatility depends on the fractional composition of the fuel. The starting and warm-up characteristics, a certain part of gasoline should vaporize at the room temperature for easy starting of the engine. But engine warm-ups in the temperature will gradually reach the operating temperature. Next one, operating range performance. In order to obtain good vaporization of gasoline, the low distillation temperatures are preferable for in the engine operating conditions. Better vaporization tends to produce more, but that is more uniform distribution of the fuel and to the cylinders, as well as better acceleration characteristics by reducing the quantity of liquid droplet in the intake manifold. So in the operating range of performance purely depends upon that the beginning low distillation temperature and also the better vaporization is tends to produce both more uniform distribution of fuel and as well as the better acceleration characteristics and also to reduce the inlet droplet quantity of the inlet droplet in the liquid droplet in the inlet manifold. The crankcase dilution. The liquid fuel in the cylinder causes the loss of lubricating oil, which destroys the quality of lubrication and tends to cause the engine through the damages through the engine through the increased friction. The low distillation temperature to ensure that all the gasolines are vaporized at the time by the time the combustion starts. The vapor lock characteristics. High rate of vaporization of gasoline can upset the carburetor metering, even also stop the fuel flow to the engine by setting a vapor lock in the passage. This characteristic demands the presence of relatively high boiling point characteristics throughout the distillation range. Anti-knock quality. Abnormal burning detonation in the SI engine combustion chamber causes a very high rate of engine excessive temperature pressure inside the cylinder. It affects the thermal efficiency. These are the important qualities or characteristics of the fuel for SI engines. Next, we will go to discuss about that. That is anti-knock quality. Properties of the fuel purely depends upon the self-ignition characteristics of the mixer and very largely with the chemical composition and molecular structure of the fuel. The anti-knocking property of the fuel is purely depends upon the self-ignition characteristics and as well as purely depends and also depends on the chemical composition and molecular structure of the fuel. And gum deposit. Reactive hydrocarbons and impurities in the fuel tends to oxidize upon the storage and form a liquid and solid gummy substance. In the gum increases with increasing concentration of with rise in temperature and while with exposure to sunlight and contact with the metals. Next, we will go to discuss about that important qualities of the CA engine. The knock characteristics. The knock in the CA engine occurs because of ignition lag in the combustion of the fuel. That is, between the combustion of the fuel between the time of injection and time of actual burning. That is, the knock in the CA engine purely depends upon the ignition lag. Ignition lag is defined as the time duration between the time of injection and time of actual burning. So hence in the foot CA engine fuel would have a short ignition delay with ignite more readily. Furthermore, ignition lag affect the starting and warm up and leads to production of exhaust smoke in the CA engine. The fuel will have a C10 rating sufficiently high to avoid the knock and fuel sufficiently volatility characteristics and operating temperature to produce the good mixer and combustion. Next one, starting characteristics. The fuel should help in starting the engine easily. The requirement demands high enough volatility to form a compatible mixer readily and high C10 rating in the order that self-ignition temperature is low. Smoke and odor in the fuel should not promote the either smoke or odor in the engine exhaust. Good volatility is the first prerequisite to ensure the good mixing and before complete combustion. Okay, the volatility characteristics very important to ensure the good mixing for the complete combustion. The CA engine fuel should be able to flow through the entire flow in the strainer under the lowest operating temperature to which engine subjected to. That is corrosion and wear. The fuel should not cause the corrosion and wear of the engine component before or after combustion. These requirements are directly related to the presence of sulfur as an residual in the fuel. Okay, then the handling easy. The fuel should be a liquid that will ready flow under various conditions that are encountered. This requirement is measured by the pour point and flash point of the fuel. And the fuel have a high flash point and fire point. It is in the fire point and flash point. It plays the vital role in design of the engines also. The flash point is the lowest temperature at which the flash will occur. The fire point is in the lowest temperature, the flash will sustain at least 5 seconds. So it is mainly influence the design of engine also. Next one, rating of SI engines. The resistance to knock is the extremely important characteristic of the fuel for SI engines. So these fuel differ widely in the ability to resist the knock depending upon the chemical characteristics. The fuel, the resisting characteristics purely depends upon the chemical characteristics. And satisfied rating method for comparing the anti-knocking quality of various fuels are established. The chemical, in addition to chemical characteristics, some other operating parameter also there, such as fuel air fuel ratio and timing, dilution, engine speed, safe of the combustion chamber, ambition conversion, and compression ratio. These also tends to knock the engine cylinder. So chemical characteristics and operating characteristics also influence the knock. And in order to determine the knock characteristics of the fuel in the engine and its operating variables must be fixed at standard values. The anti-knock value of the fuel is determined comparing with the anti-knocking property of mixing of two reference fuel. One is isooctane, another one is normal octane. Because the isooctane is a very good anti-knocking characteristic, is rating as 100 octane number. The normal octane is a very poor anti-knocking quality. It's given as a 0. The comparing two fuel, we get the anti-knocking value of the SC engine fuel. That is called octane number. That is, the octane number of the fuel is defined as the percentage by volume of isooctane in the mixture of isooctane and normal octane, which exactly matches the knocking characteristics, knocking intensity of the fuel in the standard engine under the set of standard operating conditions. That is called octane number. The addition of certain component, tetraethyl ethyl, TTL, to isooctane product fuel get greater anti-knock quality. Next, we will go to discuss about that rating of CI engines. Okay, before we are concerned the rating of SA engine fuels, the knocking characteristics purely depends upon the chemical characteristics and as well as the operating parameters. And also the octane number is determined based on the two reference fuel. One is isooctane, another one is normal octane. Okay, next we will go to discuss about that CI engine. In CI engines, knock resistance depends on the chemical characteristics as well as operating and design conditions of the engine. The knock rate of the fuel is found by comparing the fuel under prescribed condition of the operating condition for special engine. In the fuel the cetane number is defined as the percentage by volume of cetane in the mixture of normal cetane and alpha methyl naphthane. That is, it has the same ignition characteristics as when combustion is carried out the standard engine with specified conditions. That is called cetane number. Since the ignition delay is primary factor for controlling the initial auto ignition in CI engines, the ignition delay is the time duration between the time of injection and time of actual burning. That is called ignition delay. It is the vital role in controlling the knocking characteristics. It is reasonable to conclude that knock should be directly related to the ignition delay of the engine. So knock resistance of the diesel oil can be improved by adding some small quantities of component, amyl nitrate, ethyl nitrate, and etc. These two components added, that is, these components are act as additives. Some additives are added to increase the knock resistance of the fuel. And next we will go to discuss about the stages of combustion in SI engines. The combustion takes place, that is, air fuel mixture is in carburetor. Air fuel mixture is entered into the combustion chamber. Here in SI engines, the homogeneous combustion takes place because air and fuel is each molecules of the air and fuel is equally mixed in combustion chamber. Equally mixed in carburetor. So this in SI engines, homogeneous combustion takes place because each and every molecules of the fuel and air equally mixed. Okay, now we will go to discuss about the P theta diagram, that is crank angle, pressure and crank angle diagram. Okay, first one, that is called ignition lag. Two, that is called position 2 from B to C, that is called propagation flame, that is called third position, that is after burning. After burning, okay, the point A, the spark will occur up to B, that is called first stage, ignition lag. Ignition lag. After that, in the propagation, flame will occur. This starts with the help of spark plug. The spark will occur. The propagation of flame is propagated through the from one end of the compression to another entire combustion chamber. That is the peak temperature it will reach. Okay, that is in the dotted line mentioned, that is called motoring cycle. First, the point A to B referred as the ignition lag, that is preparation phase. The growth and development of self-propagating nuclei of the flame takes place. Once the spark will occur, the A to B, that is preparation phase, that is called growth and development of self-propagating nuclei of the flame takes place. This is purely depends upon the both temperature, pressure and nature of the fuel and proportion of the residual gas. Okay, that is chemical process depends upon the temperature, pressure and fuel conditions, then residual gas, and also depends upon the relationship between the temperature and rate of reactions. Okay, the second stage, that is B to C, that is called physical one. It concern the spread of flame throughout the combustion chamber. From B to C, the spread of flame throughout the combustion chamber, the spread of flame throughout the combustion chamber. The second stage is the first measurable rise in pressure. And we will see that indicator diagram where the line of combustion departs from the on-line point B. Next, during the second state, flame propagates practically at the constant velocity. Heat transfer to the wall is low because only a small part of burning mixtures comes in contact with the cylinder wall during this speed. The rate of heat release largely depends on the turbulent intensity and the reaction rate, which is purely depends upon the composition. Okay, the heat transfer to wall is very low because small part of burning mixture is contact with the cylinder wall in this particular period. That is called second stage. And the rate of heat release depends largely on the turbulence intensity and also reaction rate. Okay, the pressure rise in the proportional to the rate of heat release during this speed. The combustion chamber volume is constant since the piston is near the top dead center. Next one, the starting point of the third stage usually taken as the maximum pressure is reached in the on the PV diagram. That is called starting point of the third stage. The flame velocity decreases during this stage. The rate of combustion becomes low due to the low flame velocity and reduced flame surfaces. So when the expansion stroke starts before this stage, the piston moves from TDC to PDC. So no pressure rise during this stage. Last one, the stages of combustion in CI engine. Okay, in SI engine, ignition lag, preparatory phase and after burning. That is the ignition, that is here combustion is purely depends upon the chemical composition of the fuel and design of the engines and temperature. Here we will go to discuss about that stages of combustion, that is ignition, delay feed or flame frame combustion, uncontrolled combustion, controlled combustion and after burning. First stage, that is start of injection and start of combustion. That during that period, that is called PV diagram, that is okay, degree of angle, P theta diagram, pressure and crank angle. The start of injection and start of combustion, that is called ignition, delay period. Okay, 2 to 3, combustion of pressure. Okay, and 3 to 4, that is called injection period. So in the dotted line mentioned that non-firing, that is called motoring cycle. Okay, then we will go discuss about detailed discussion about that. Combustion of CA engine, the ignition delay period or free flame combustion. The fuel does not ignite immediately upon the injection into the combustion chamber. There is a definite period of inactive between the time of injection and actual burning. This is known as ignition delay period. In the ignition delay period, divided into two, that is physical delay and chemical delay. In already we told that delay period is in the CA engine is a very great influence the engine design and performance. Okay, the delay period is in CA engine crucial factor very and also influence the engine design and performance. The exact extreme temperature because of is both combustion rate and takes place also influence the engine starting abilities and smoke in the exhaust. Period of rapid combustion, it is called uncontrolled combustion. In this phase, the pressure rise is rapid. During the delay period, considerable fuel is accumulated in the combustion chamber. This accumulated fuel droplets burns very rapidly, causes the slip rise in pressure. The period of rapid combustion counted at the end of the delay period at the beginning or beginning of the combustion at the point pressure on the indicator. This pressure is called peak pressure. Okay, peak pressure or maximum pressure during this period. And also uncontrolled combustion phase, because it is difficult to control the amount of burning or injection during this process. Pressure reached during this period rapid combustion will depend on the duration of delay period, and also that is delay period. No, the longer the delay period, more rapid and higher pressure rise. This more fuel would be presented in the combustion chamber before rate of the burning comes under the control. Period of controlled, the rapid combustion period followed by the third stage controlled combustion. The temperature and pressure in the second stage are so high, the fuel droplet injected burn almost as they enter and find the necessary oxygen. Any further pressure rise can be by injection rate. The controlled combustion is assumed at the end of the cycle temperature. Period of after combustion, the combustion does not stop the completion of injection process.